section 1.5c, we're going to talk about maximums and minimums, also even-odd functions. Maximums and minimums, we're going to be using the calculator. Even-odd is going to be no calculator. So we'll go ahead and get started with the definition for maximums and minimums. You can go ahead and jot this down. I'll give you a little bit of time. This would be like our mathematical definition, what we would see in our textbook. So basically, maxima and minima are defined as points where we change from increasing to decreasing. Now we do have this word in front that says relative. You may also hear another word sometimes. It's the word local. And what that word means for us is it's not necessarily the maximum of the function. Like it's not the highest value it ever gets to. That's called a global maximum or a global minimum. For the whole function, the highest it ever is. Local or relative means it's a maximum relative to the rest of the graph near it. So when we look at this point right here, relative to the points around it, it is a maximum point because it's turning directions. There can be multiple maximum points, and maxima is the plural for maximums. So that's what we mean by the phrase relative. These are the steps for a Texas Instruments, probably like an 83 or an 84. If you have the TI Inspire, if you have the Casio graphing calculator, your steps are going to be different. So I wouldn't jot this down into your notes. And your best friend is going to be Google. Because if I were to help you do maximums and minimums on your calculator, I would need to Google it. And what I normally do is I would Google like maximum, minimum, TI 84. And then a YouTube video will pop up and it will tell me how to do the thing I want to do. Okay? So by all means, if you are working with a calculator other than the TI 83 or 84, you are welcome to Google in class. Don't turn your volume up on your YouTube, but you might be able to find something that tells you how to do max or min. Or you can just kind of play around and see what happens. I see Paul and Olivia, you guys have the same calculator, so you guys can work together too. Like, hey, I found it. Here it is. That kind of thing. So, Justin, do you want to, oh, you have a calculator. Never mind. I thought you only had your phone out. Great. I would definitely practice on a calculator, not your phone. You can use your phone for homework if you have an app or something. But you'll only be allowed to use a calculator on a quiz or a test, not your phone. So you've got to know how to use a calculator. And we're going to do this on the screen together here momentarily. So if you jot these things down, we'll kind of go through the buttons. And of course, answer questions. Help your pod members out if they're having trouble finding the button or they get lost. Okay, bring them back up to speed. Yep, she'll catch up. Okay, we're going to do this example at the bottom of the screen, negative x squared plus 13x minus 2. So I'm going to pull my calculator up on the screen. And I'm just in like the blank screen that I normally am. And we're going to do that first step, which is go to the y equals menu. I'm going to zoom out real quick so you can see a little bit more of my calculator. Underneath the screen of a TI, those 5 buttons are really for your graphing stuff. So y equals, window, zoom, trace, graph. Those things all have to do with the graphing window. So we're going to hit y equals. Now, most of us should have a list of y equals come up. If yours has any other letter besides y, like r equals, let me know we need to change your mode. Okay. And then we're going to type in that equation, negative x squared plus 13x minus 2. I do want to point out one thing to you. So look down by the decimal. There's a little negative sign right next to it. I'm going to type that. And then you don't have to do this, but I'm also going to type the subtraction sign on the TI. Do you see how these two things are different? Negative, subtract. The Texas Instrument, it matters which one you use. On the Casio, what's cool is it accepts either one. Like it calls a negative subtraction and a subtraction negative, which is smart. In the Texas Instrument, we have to be very careful. So when we want to do negative x squared, we have to hit the negative down by the decimal, not the subtraction sign. So I'm going to go back over, and then I'm going to do x on top of that. To get your variable, you actually have a nice button that you can hit. You see your colored second and your colored alpha button. Right next to it says x, comma, t, comma, theta, comma, n. That's your variable button. It will give you a different variable depending on what mode your calculator is in. Since we're in function mode, we should get x. Okay, so I'm just going to type that, and you should see an x appear on your screen. So I've got negative x squared plus 13x minus 2. And notice I had to, on this one, use the subtraction sign so it looks longer. Okay. If you ever hit like go after this and then it tells you a syntax error, it's probably going to be blinking on your negative or your minus sign, so it means use the other one. Okay. Is everybody okay up until this point? All right. To graph, most of you could probably just hit graph right now, but I'm going to show you some zooms so that you're comfortable with that if you ever change zooms, how to get back to normal. So hit that middle zoom button, and these are all your options for zoom. If you're ever like looking at your graph and it's like way far away from the origin and it's not at all like a normal regular graph, then you want to go back to zoom 6, which is zoom standard. So I'm going to just type 6. You can scroll down and hit 6, but I like to just type because it's faster. And what that does is it gives me a window with the origin at the center, and it goes from negative 10 to 10 on the x and negative 10 to 10 on the y. So it kind of gets me back to normal. Now, what does this graph look like right now? It looks like a line, but when I typed in the function, what type of function did I type in? Quadratic, so I know that my graph is actually not a line, it should be a parabola. So Chloe, I must not be seeing my whole graph, right? So now I can say, okay, well that's not my whole graph. Let me change my zoom. So there's a couple of different ways you can do it. You could go to a window and you could change like your y maximums and minimums. So it goes down to negative 10 and positive 10. So maybe I would change it to like negative 50 and 50, and then I could scale by tens. So then I'm going to graph and see what it looks like. Okay, I'm getting a closer image. Or you could have went to zoom. Okay, so I'm going to go back to zoom 6. So I can see now, I can see the parabola there. Or I'm going to go back to zoom 6 where it looks like a line. And then I could have gone to zoom. And I could do zoom out. Now the thing about zoom out and zoom in is if you hit it, it doesn't look like it changes, but there should be something blinking on your screen, and then it's saying like, where do you want me to zoom out from? So do you want me to zoom out from the center, or should I move my cursor and zoom out from over here? So it's not going to be as centered as it once was. Okay. So then I get a different picture. Okay. So whether you're changing the window or you're doing the zoom, either is acceptable, but we probably want to see that parabola shape. How are my Casio people doing? You figuring things out? What was it? Negative x squared plus 13x, and then a minus 2. Paul, how about you? Figuring some things? Oh yeah, so I would go right there, and I would type negative. So negative x, which is your x squared plus 13x. Yeah, x squared. No, you don't. And then plus 13x minus 2. Okay. Are we okay? Catherine, getting it? Do you have something in your y equals? Oh, yours, see, sometimes up at the top it's like thinking and like it's turning or there's like this little line going. Yours is stuck, so I'm going to suggest we shut it off and then turn it back on. It's just like a computer. When in doubt, turn it off. Pop out a battery. Do whatever you have to do. I would say draw. Yeah, F6. Paul, have you gotten yours going yet? Maybe you should sit by Paul for right now, and you guys can probably offer each other. I actually don't know how to use that, so I would have Googled it. Okay. You hit Zoom and 6, or sorry, not Zoom 6, Zoom out, and then it'll be blinking, and you have to hit Enter again so it zooms out.
Oh, there we go.
Okay.
Yeah.
Any other questions? We can kind of see the whole graph. Catherine, did you get yours? Yep. Okay, so now we can actually find the mins or max. So let's do second trace. So we're in calculate. We're going to choose maximum because the graph had a maximum, right? If the graph looked like it had a minimum, I would choose minimum. And now it's going to ask you 3 questions. So this is the weird part about it. Make sure you're listening. It's going to ask you left bound. Then I'll ask you right bound, and then it'll say, do you want me to guess? So for left bound, it means take your cursor, stay on the left side of the maximum, but probably get closer to the maximum or as close to the maximum as you can. So use your right and left arrows and inch yourself closer to the maximum. Once you're on the left side of the maximum, close to the maximum, hit enter. And now it's asking a second question at the bottom of the screen. What's your right bound? So now you got to get on the other side of the maximum. So I'm going to use my right. I'm up to 40.24 and then I'm down to 39.95. So I've crossed the maximum because now it's going down instead of up. So I'm going to hit enter. And you see my calculator is putting these 2 arrows there. So it's saying, do you want me to look in between these 2 arrows for a maximum? Yes, I do. So I have to still hit enter when it says guess, question mark. Yes, my maximum, it looks to me like 6.5, 40.25. Now, some of you might have like 6.499, but it's going to be really close and we would round to the same number. Okay? So everybody try that and see if you can get that going. Let me know if you're having trouble. Find anything to grab? Okay. Did Olivia get hers to grab? Do you know how you got to grab? Share that. Oh, that's just because of the Zoom or whatever, or your window. It's okay. Remember, left bound, you need to be on the left side of your graph, hit enter. Or maximum. Right bound, be on the right side.
I put the left one like one lower than the other one.
Y equals. And I would just, like yours is hard to see, right? Do you agree with me? So do Zoom 6. Just go back to normal.
That's going to be my quiz that gets thrown.
And then once you're there, it'll go back to that like normal. Just put like 6%, and then maybe do Zoom out, so discrete. And then it's blinking like where you want to zoom out from. If that's the center, just hit enter. Over time. So when you get crazy, just go back to Zoom 6, okay? Yeah. Yeah. Okay. Now, while I'm helping Allie, I'm going to change over my slide because we can also use our calculator to find zeros, and it's very similar. So you can decide what you want to write in your notes about finding zeros on the calculator. The only difference is when you go to second trace, you choose 0 instead of max or min. What's happening? Okay, go to y equals. And you see it over there, it has like some weird picture. So I think if we just hit enter, so So then it'll be like less than, and you want it to be just the line. So is this like a siblings calculator?
No, I like my mom just like got it from
Yeah. Okay, that's fine. Yeah. Maybe you just were clicking on it. Now hit zoom or graph. Okay, so now it won't be shaded. And now zoom out. Great. And then you have to hit enter. It's at the center right now, and it should show you a whole picture. Okay, so if you're doing a problem that is no calculator, quiz, or test, and you're asked to find zeros, then you have to know how to solve an equation. Set the y equal to 0, factor to solve, reverse PEMDAS to solve, whatever that may be. If you have access to a calculator or you're allowed to use a calculator, you can also find the zeros on the calculator. So it's the same process. I'm going to use the same equation. Okay. But this time when I go to second trace, instead of choosing minimum or maximum, I'm going to choose the 0 option. So I can choose 0, and then it's going to ask me the same 3 questions. Left bound, right bound, guess. So it's saying get on the left side of your 0. If I want to find this 0 down here, I'm going to hit to the left, to the left, to the left, to the left. I can tell that as like I'm going further, I'm like positive over here. So to be on the left side of my 0 must mean I'm below the x-axis. So those are negative numbers. So I'm going to choose this one because my y value, even though I can't really see left and right there's like a lot of stuff going on, I can tell that my y value is negative right there, so that must be on the left side of my 0. And then I'm going to use my right arrow to get over, and as soon as it's positive, then I'm on the right side of my 0. So I've moved to the right, and now I've changed signs. So now it's positive. So I'm going to hit enter, and then I hit enter again, and it looks like my 0 is at like 0.156. That decimal is not nice like the other one that rounded to 6.5, so that probably means to find this 0 for this quadratic, I would have used quadratic formula and come up with a radical that doesn't simplify nicely. So it's something irrational. Does anybody have any questions on their calculators that they need me to address? Do it one more time? Okay, so if you're finding a 0, second trace, instead of min or max, choose 0. If I want to find the other 0 on the other side, I want to be on the left side of the 0. As I'm coming from the left side is this positive part, right? So I'm going to choose like my last positive number. So that will be on the left side of my 0. So I'm going to choose this value right here where my y is 4.25. That's my left bound. And then when I hit right, I immediately jump to the negatives. So I've crossed my 0 because I crossed the x-axis, hit enter, and then it asked me to guess, and now I get 12.884 or 844. So you just need to be thoughtful about, like, am I on the left side of this point, max, min, 0, whatever, am I on the right side of this point? You're narrowing the place that the calculator is looking for your number, or your maximum or minimum. Okay? Now, if you have a different calculator or you're just like having trouble, stop in after school, before school. I will definitely help you with your calculators. We just don't always have time for that in class with lots of different calculators. Okay? Okay, so set your calculator aside for right now. We're not going to need it for even or odd. And you'll want to jot this down in your notebook. Even functions are functions that are symmetric to the x-axis, or sorry, y-axis. Only functions symmetric to the y-axis can be classified as even. I have an image of an even function. Looks like a quadratic function again. Notice that we would all agree it is symmetric to the y-axis. I know it's hard for you to see from there, so I'm just going to list off some points on this function. And we're going to compare the x and the y values over the reflection. Okay, so you're going to be looking, what's the same, what's different? So I'm going to do, let's see, this point right here, like I'm going a little bit more than 1 to the right, so I'm going to say like 1.2, and then I'm going down 2. Okay. This point right here looks to be 1, 1. And this point right here, maybe I'm going like 0.53. Okay, halfway, and then 3 up. So I labeled some points over there. And then if I look at the points that are reflections over the y-axis, this point right here, now I would be going left 1.2, so that's negative 1.2, and I'm going down 2, so negative 2. This is left 1, up 1, so that's negative 1, 1. And then this point is maybe negative 0.5 and 3. What are you noticing in the XY ordered pairs there? Chloe?
The Y's are the same, but the X's
X's are
are negatives.
negatives or opposites of each other, and the Y's are still the same. So here, make sure you get this in your notebook, the algebraic test for even functions, and I'm going to be checking your algebraic test, is to test, is f of negative x equal to f of x? F of negative x equal to f of x. That does what Chloe said. You're putting in a negative x, the opposite x, but you're getting out the same y. The other type of function is an odd function. So the definition of an odd function is that it's symmetric to the origin. And you would have talked about odd functions, or not odd functions, but symmetry to the origin back in geometry. When things are symmetric to the origin, we might say that they have rotational symmetry, meaning if you rotate them 180 degrees, they map onto themselves. So if I were to rotate this 180 degrees, it would look like the same picture. And again, I'll just pick out some points here and label them. So I'm going to pick out this minimum over here. That looks to me like 0.9. I'm not going quite all the way 1 to the right. And then it's like negative 2.1. And the maximum point over here looks like I'm not going 1 to the left, so like maybe negative 0.9, but then I'm going up 2.1. And I'll just do one set of points right there. What do you notice happening with your x's and your y's? Someone besides Chloe.
They're both opposites.
They're both opposites. So not only is x changing sign, but so is y. So then our algebraic test for odd functions is, does f of negative x, putting in the opposite x, equal negative f of x, the opposite y? So make sure you jot down those two algebraic tests. F of negative x equals f of x for even. F of negative x equals negative f of x for odd. Now, when I do an algebraic test for even odd functions, I basically go in this order every time. So my first check is it even? If yes, I can stop. If no, I keep going. Is it odd? If it works, yes. If no, neither. That's all the work I would ever have to do, 2 checks. Okay. So let's do an example. I'm going to do this one on the left. F of x equals 2x cubed plus 3x. So I always start with a check for even, which I know my check for even is the question, if I put in a negative x, will I still get out the same y? So that's my question. Does f of negative x equal f of x? Okay. Well, I already know what f of x is, right? 2x cubed plus 3x. So I need to know, is f of negative x the same thing? And the only way for me to know that algebraically is to work it out. So I've got to show my work for f of negative x. F of negative x equals, and then I would plug in negative x's everywhere I see x. 2 times negative x cubed plus 3 times negative x. So I'm just doing a direct substitution with negative x. Okay. You've got to like simplify this algebra. So think about when you take a negative and you raise it to an odd power, it comes out negative. So whatever negative x times itself 3 times is going to be negative x cubed. So negative x cubed times 2 is going to be negative 2x cubed. And 3 times negative x is going to be minus 3x. So there's my f of negative x. Is f of negative x the same thing as f of x? The original? No. Okay. So it's not even. Now I can test for odd. To do odd, the nice thing about this is the odd check is if I put in negative x, do I get out negative y? So you already know what f of negative x is, right? It's negative 2x cubed minus 3x. You've done the work. Now you just have to figure out what negative f of x is. So negative f of x means make the whole thing negative 2x cubed plus 3x. And when I say the whole thing in math, it's a set of parentheses. If you make the whole thing negative, you change all the signs, distribute. So negative f of x is equal to negative 2x cubed minus 3x. Is negative f of x the same thing as f of negative x?
Yes.
Yes, so it's odd. So I'm showing that work. Now, if I had answered no, I have no more work to do, I just say neither. If I had answered yes, done the first, I wouldn't keep checking. Only do one. Questions about that? Okay. Definitely spend some time on your homework assignment practicing the even odd with the algebraic check. I am very aware that you could type these into your graphing calculator and see the picture and tell me even or odd based on symmetry, but it will be on the no calculator part of your quiz or test. So you'll need to be able to do that without a calculator, okay? So I want to be able to see this algebra. If you're confused by function notations, you should be stopping in before after school for some assistance there. Your homework assignment is on your gold sheet. I actually think there's less problems, like maybe it starts at 47, because I think those are your increasing, decreasing intervals. So here's your homework assignment, and I'm going to pass back your quizzes and talk about those here.